So our group name is Brainiacs. We are from.
So what is rational function? Rational function is a visual representation of an equation that relates with two polynomials, typically in the form of f(x) equal to px over qx, a polynomial, and qx not equal to 0. So what you guys need to know in this topic is you guys need to know four main things, which is vertical asymptote, horizontal asymptote, x and y intercept, and lastly you guys need to know how to sketch the graph using the above information. So in this video, me and my friend will teach you guys how to find and calculate the four main things that I have mentioned before. So let's go. Okay, for the first question, given a function f(x) equal to 4 minus 2x over 1 minus 3x, and the question is find x-intercept and y-intercept of f(x). Okay, for the first step, you guys need to let y equal to 0 because we want to find x-intercept. So the equation will be 4 minus 2x over 1 minus 3x equal to 0. So the second step, we need to find x. So 4 minus 2x equal to 0, and we need to move 4 to right side, and the equation will be negative 2x equal to negative 4, and we need to single the x, and we need to move negative 2 at the right side. So the equation will be negative 4 equal negative 4 over negative 2, and the last answer is 2. So x equal to 2. So for find y-intercept, we need to let x equal to 0. We will use the same function, which is 4 minus 2x over 1 minus 3x. So we need to substitute x value into x. So the equation will be 4 minus 2 substitute x with 0 over 1 minus 3 substitute x with 0. So the answer will be 4 over 1. And the last answer will be 4 y equal to 4. So the coordinate will be 0, 4.
Question 2. Given a function f(x) equal to 4 minus 2x per 1 minus 3x, find the vertical and horizontal asymptotes of f(x). Firstly, vertical asymptote. To identify vertical asymptotes, we need to look at the denominator of the function, which is 1 minus 3x. After that, we set the denominator equal to 0 and solve for x. Therefore, there is a vertical asymptote at x equal to 1 per 3. Firstly, horizontal asymptotes. To identify horizontal asymptotes, we need to look at the highest power of x in both the numerator and denominator. After that, we compare the highest power of x. If they are the same, divide the coefficient of the highest power terms, which is 2x and 3x. Just choose the x and the calculation like usual for limit x to infinity. Finally, the result of horizontal asymptote is y equal to 2 per 3.
Here we are going to find intervals where f of x is increasing. So first, to find interval, we are going to use quotient rule to find derivative of f of x, which is vu prime minus uv prime over v square. And we see here our f of x, the numerator is u and the denominator is v. So we find the u, which is 4 minus 2x. The u prime is negative 2. Meanwhile, v 1 minus 3x. 1 minus 3x. The v prime is negative 3. And then we substitute the value into the formula and simplify the numerator. Then we get the answer f prime of x equals to 10 over 1 minus 3x squared. Next, we let f prime of x equal to 0. F prime of x equal to 0 has no such x value. So we take the denominator to find the value of x. Here we got 1/3 as the value of x. And then to get more specific interval, we put it into the real number line. Then we put the 1/3 in the middle, and to the left side we get negative infinity to 1/3, and to the right side we get 1/3 to infinity. Then after we get the interval value, we put the interval value in the table, which include interval, test value, and sign of f prime of x. So here our test value for our first interval is -2 because we need to pick the number between negative infinity to 1/3. So for our second test value is 2, and after we substitute the test value into the f prime of x, we get both positive number. Since we get both of positive value, so we just take the negative infinity to 1/3 and 1/3 to infinity as our increasing interval. Okay. We don't have decreasing interval because there's no negative value at the sign of f prime of x side. So we just got our answer here.
So the first question is, find the interval where fx is concave up and concave down, hence determine the inflection point. So first of all, we need to find the prime double prime of x from the f prime x. In this question, we have to apply chain rule to get the f double prime of x. It is because they have a power to differentiate, and then after get the answer, we need to draw the table to know whether the interval is concave up or concave down, such as the test value of the sign that form f double prime of x. After using the chain rule, then we will get the answer of f double prime of x. So this is the table to determine either the sign of f double prime of x is concave up or concave down. In this table, we have interval where it is negative infinity and 1/3, and then 1/3 to positive infinity. And then we have the test value, sign of f double prime of x, and then the conclusion the sign is concave up or concave down. The next one is find the inflection point. To find the inflection point, we have to substitute x with the 1/3 that we find in a vertical asymptote. And then we have to calculate it. If we can calculate it, the inflection point will be undefined.
Okay, for the last question, sketch graph of fx using information from question 1 to question 4. So, for the first step, you guys need to sketch y-intercept and x-intercept. As you guys can see, I choose to put 1 cm with two number. So 1 box equal to 2. Okay, for the second step, you guys need to refer back at the question number 2, because question number 2 have vertical and horizontal asymptote value. It is because we need to take the value to sketch the new line with dotted line at the graph. You guys can see the example at the slide that I have shown at you guys. Okay, for the third step, you guys need to mark y-intercept and x-intercept value at the graph x and y-intercept. Then you guys need to look back at the previous question about concave up and concave down to make sure if the concave up or down at the graph. So as you guys can see, at the left side is concave up and at the right side is concave down. So we need to sketch the line at a that across x-intercept value for concave down and across y-intercept value for concave up. Lastly, we need to make sure that our graph line not touching the asymptote line.
Question is, we can sketch the complete graph with the information that we get from the solution that we make, and also we can determine either the graph will concave up or concave down, and also determine either it is increasing or decreasing.